Hello everyone, my name is Chelsea and today we are going to go over Chapter 9 Geometric Figures with you. Let me get it pulled up here. And we're just going to go over a few different questions throughout Chapter 9. And first, we are going to start out with this figure given here. And we're asked to find all the measures for the numbers provided. Now, you'll see that there's two spaces where there are no numbers here and here. Let me see if I can find my little laser pointer. Here we go. Right here, there is no number, and right here. Those are already given to us. We have a 63-degree angle here and a 61-degree angle. So first, to start off, we are going to, the interior of this triangle here, we're going to add those together, and that's going to give us 180. But since we're not given the third degree here on number 7, what we do is we just deduct the 63 minus 61 from 180, which is going to give us 56. So let's see here. There we go. Next, we're going to look at angle 3. And it is, or I'm sorry, angle 1. I'm so sorry. 1 and 7 are corresponding, which basically just means they're parallel to one another or they're the same. So 1 is going to be the same as 7. So it's also 56 degrees. Next, we're going to look at angle 2, which is vertical to. And if you'll notice, it's vertical to this angle here, which means it's on the opposite side of. So 2 is on the opposite side of this already given degree of 63 degrees. So vertical to means they're the same as well. So that is also going to be 63 degrees. And next, we're going to look at angle 3. And it is corresponding. If you remember, corresponding means they're parallel or basically the same thing. So angle 3 here in the table shows that it is corresponding to the angle labeled 61 degrees down here. So those are going to be the same as well, 61 degrees. Next, angle 4 shows here that it's in the vertical to column. So vertical to, again, remember that means it's on the opposite side of that angle. So angle 4 here is on the opposite side of this ray of the 61. So that is also going to be 61 degrees. Next, we're going to look at angle 5 here. And it is also vertical to another angle. It's vertical to a number on the same ray here. Could you guess which one it is? That's right. It's vertical to angle 1. So those are going to be the same as well. So it's also 56 degrees. Angle 6 down here on the bottom left, it's in the chart, it shows it's supplementary to another angle. Now supplementary, what that means is that if you add the angles together, they're going to give you a value of 180 degrees. So it is going to be supplementary to this angle here of 61. We need to be able to add those two numbers to get 180. So if you just simply subtract the 61 from 180, you're going to get 119 degrees. Angle 7, we've already done here. As you can see, it was the 56. It was one of the first ones that we did. Angle 8, over here right beside angle 7, is labeled as supplementary over here on our little table. Let me move myself there. Okay, so it says that it is supplementary to the angle labeled 56 degrees. So again, remember, supplementary means that we have to be able to add those two numbers to get to 180 degrees. So if we deduct or subtract 56 degrees from 180, we are going to get 124 degrees. So angle 8 is 124 degrees. Angle 9 on the vertical or on the table here shows it's vertical to another angle. So it is going to be vertical to the angle that is labeled 61. And remember, vertical to means it's on the opposite side. They're still going to be the same value, but they're just opposite. So if you were to flip that over, it would be laying on top of that angle we have labeled 61. So angle 9 is also going to be 61 degrees. Angle 10 is also vertical to. It's vertical to angle 6, so they're both going to be 119 degrees. Angle 11 is going to be vertical to angle 8, so that means it's 124 degrees. And angle 12 is vertical to angle 7, so it's 56 degrees. And next, we have this figure here. And we're asked to find the some more angles, and we are given 74 degrees on angle C, 26 on angle B, and then the rest of them we're asked to find those angles. So if you look here in my little chart that I have provided, it shows the corresponding angles, which as we talked about before means parallel or the same, and then supplementary to means they add together to make 180. But first, let's look at the overall triangle that we have here, the one labeled A, B, and C. And it's the largest of all of them. And if you'll see, we have one labeled 74, one 26, and one is just labeled with an angle 1. We need to find that degree. So the interior angles of a triangle will add up to 180. No matter what type of triangle it is, they're going to add up to be 180 degrees. So to find that number 1 angle, we're just going to subtract 74 from 20, or 74 and 26 from 180, which is going to give us 100. So angle 1 is equal to 100 degrees. Next, we're going to look at, sorry about that. We're going to look at the corresponding angles. We have 3 and 8 that are corresponding here. They correspond with angle 1, so they're the same. They're parallel to that angle. So they're also both going to be 100 degrees. And then we're going to look at angle 2 plus angle 3, which is going to give us the 180. If we add those together, they give us 180. So if we add those two together, we're already given the angle, we've already found the angle 3 is equal to 100. So we're going to deduct that 100, subtract it from 180, which gives us our angle 2, which is 80 degrees. Next, we're going to find angle 5. It says here in our table that it is congruent to angle 1, angle 3, and angle 8. It is the same as we've already gotten 100, 100, and 100. So angle 5 will also be 100. Next, we're going to look for angle 7. And if you see over here, I have it listed. It's under the supplementary 2, which means if we add angle 7 and 8 together, they're going to get 180. So we already have angle 8 as 100. We just need to find out what angle 7 is. So we're going to subtract the 100 from 180, and that's going to give us 80 degrees. So now we know angle 7 is 80 degrees. Next, we're going to look at angle 4, which shows it's under the corresponding angles down here on our little table. It says that it is corresponding to angle B, which means it's parallel to or the same as angle B. So angle B is labeled as 26 degrees down here. So that means angle 4 will also be 26 degrees. And then lastly, we're going to find angle 6. It's also a corresponding angle. It corresponds to angle C, which is labeled 74. As you can tell, they're both parallel lines. If you look here, C goes all the way down, and then this one here, 6 goes all the way down. They're parallel to one another. So angle 6 is going to be the same as angle C, which is 74 degrees. All right, and the next problem, we have this figure here. It looks kind of like a triceratops. We are given some degrees for these different angles. We have 3y, 7y, and 12y, and we need to find out what those are equivalent to. So the sum of the measures of an interior angle of an n-gon is going to be the formula to find that is n minus 2 times 180. So what we're going to do, we're going to use that formula, and we're going to find the different angle degrees. So remember that n is equal to the number of sides. So in our formula, we're going to take the number of sides minus 2 multiplied by 180. If you count here with me, let's see. If you count with me, we have 1, 2, 3, 4, 5, 6, 7, 8, and 9 sides. We have 9 sides. I'm sorry, 8. I got a little happy there. So we have 8 sides on this n-gon. We subtract that by 2, and then we multiply by 180. So we have 6 times 180 degrees, which is equal to 1,080 degrees. Next, what we're going to do, we're going to add all of those angles together. So we're going to have 3y plus 3y plus 3y plus 7y plus 7y plus 7y plus the two 12y's. And we're going to come up with 54y is equal to 1,080. Next, to get that y by itself, remember we just need to divide by that number given, which is 54. So we're going to divide both sides, and that is going to give us y equals 20 degrees. So now we know all of these y's in here that are associated with each angle, we're going to multiply it by that number given. So 3 times 20, that's going to be 60. So all of those angles labeled 3y will be 60 degrees. And then we're going to do the angle 7y, multiply it by 20. That's going to equal 140. So each of the angles labeled 7y is equal to 140 degrees. And lastly, we have angle 12 times 20 is equal to 240. So every angle labeled 12y is equal to 240. Now, the 1080 that we got up here at the very front of the problem, very first of the problem, we got 1080. What that means is all of these numbers that we just got, if we add all of those together, we're going to get 1080. So that's a way to kind of go back and check your work to make sure you got everything correct. Alrighty, and next we need to find 3 different angles. We're going to find the interior angle, the exterior angle, and the central angle. So the interior angle formula is the one we were just kind of working with, except we're going to divide by 2. So we do the number of sides minus 2 times 180 divided by 2. Sounds like a lot, but it's super simple. So we need to find out how many sides we have for n. As you can see here, we have 9 sides. We subtract 2, then we're going to multiply that by that 180 and divide it by 9 again. That gives us 140 degrees. The exterior angle formula is just going to be 360 degrees divided by the number of sides, which again is 9 for this problem, which gives us the degree of 40 degrees. And lastly, the central angle, it's the same as the exterior angle that we just worked with. So it's 360 degrees divided by n. Again, 40 degrees. So now we're going to label them on the actual figure here. The interior angle is equal to 140 degrees. The exterior angle is 40 degrees, and it's labeled down here for you. And lastly, the central angle, which is right here in the center, is 40 degrees. Super simple. Alrighty, and next we're given a cube, and we are asked to find a tetrahedron, or we're going to label it within that cube. And all a tetrahedron is a triangular pyramid. It is composed of 4 triangular faces, 6 straight edges, and 4 vertex corners. Now the triangular faces, we'll see they're the actual 3-dimensional parts of the triangle, and the straight edges are what it sounds like, the edges. And the vertex corners are where 2 rays meet, and that is called a vertex. So we're going to use the angles D, E up here, G over here, and H here. We're going to use all of those to make a tetrahedron. So as you can see here, we used all of those angles from D, E, G, and H to make that tetrahedron in there. And again, the faces, there's 4 faces. Here's one down here, that's a face of a whole triangle. There's a face here of a whole triangle and a face here. And then this larger face we see here is the 4th one. And then these corners, the lines that you see, are going to be the straight edges. And then here are the vertex corners where the lines meet together. Next, we're going to look at a tetrahedron. It is a triangular pyramid like we just talked about. And as you can see here, it has 4 triangular faces and 6 straight edges. So we can visibly see in this picture 3 of those faces, but the 4th one we can't see because it is not a 3-dimensional shape on this screen, but always know that it is a 3-dimensional shape. So the 4th face that we would be seeing, we would look at this whole entire triangle. And then again, the edges are going to be these black lines that you see. And then we're going to have 4 vertex corners. And remember, all those are is a common point of 2 rays. So everywhere that 2 rays meet together forms a vertex. So here we have these little black dots that are going to be our vertex angles. We have 4 of those for a tetrahedron. Next, we're going to look at a octahedron. Octa means 8. So we're going to start out with the triangle, the basic triangle or triangular pyramid. It has 8 faces and 12 edges. Remember, octa means 8, so that's where we get the 8 faces. We have 8 faces and 12 edges. If you look in between each of these edges, you'll see a triangle, and that's a face. And then again, these white lines represent the edges. And then lastly, it has 6 vertices where the rays meet to make 1 point. So those are here labeled with a black dot. We have 6 vertices. And lastly, we're going to look at an icosahedron. It's a mouthful, I know. And the picture looks kind of as confusing as it, but once you kind of understand what we just went over, the faces and the vertices and the edges, it makes it much, much easier to understand. So again, we're going to start with our base pyramid. And we know that this figure has 30 edges and 20 equilateral triangle faces. So here we have all the faces. Each of these triangular faces are the green parts here. So we have one large one on each side and on the bottom, and then in between we have 2, and then we got 2 here, and then we got 2 here, 2 here. It kind of goes around 2, 2, 2, 2 if you go in a big circle. So it has 30 edges and 20 faces. The edges again are these straight lines around the figure. And lastly, it has 12 vertices, which are going to be those points again where the rays meet. As you can see here, they are again labeled with black dots. If you count all of those, we have 12. Thank you so much for watching, and I hope that helped you understand a little bit more of the geometric figures. And I hope you have a great rest of your day.